Hello, it's the law of cosines. Yes, today we're going to prove the law of cosines, and now I'm just going to draw an arbitrary triangle, as you can see here. Now, what I'm going to do is label this angle as theta, okay, and label this as C, B, and A. Of course, those are the sides. Now, law of cosine states that C squared is equal to A squared plus B squared. However, you have the additional minus 2AB cosine of theta right over here. Let's start by proving this now. Drop a perpendicular. Whoa. That's not a perpendicular. Drop a perpendicular like so. Label this line M. This shorter segment D and E. So D plus E equals A. Now, what we have to do simply is to use our SOHCAHTOA definitions of trig functions. So we know that the cosine of theta is indeed equal to, let's have a look, D over B. And we can just change this into B cosine of theta equals to D. And this further becomes our final equation. D is just A minus E, right? So A minus E is equal to B cosine of theta. And this further becomes, I'm kind of writing too much off the page here, but it's fine. This further becomes, let's just rewrite this. E is equal to A minus B cosine of theta. Now that's a lot, but bear with me. Time to solve for M using trig functions. So sine of theta is equal to M over B. Now this is pretty easy. B sine of theta is equal to M. Now we've solved for M and E. What we can do is use Pythagoras theorem to solve for the side C in this right angle triangle, right? So now this involves some amount of algebra. Let's get on with it. We know that M squared plus E squared is equal to B squared, or actually not B, C squared, right? Is that C? Yeah, C. So C squared. Now we sub in the values. B sine of theta squared plus, what was E again? A minus B cosine of theta. Okay, so A minus B cosine of theta, and that squared is equal to C squared. Simplifying by expanding, this is B squared sine squared of theta plus A squared minus 2AB. Yes, it's 2AB indeed. 2AB, I think it's a cosine of theta. You might see something jump out of you already. You might see a little bit of a clue in this, because that relates to the law of cosine. Of course, let's keep going. So then we have a plus B squared cosine squared theta. That's equal to C squared. Now what we can do here is just write B squared sine squared of theta plus B squared cosine squared of theta plus A squared minus 2AB cosine of theta. And this is the law of cosine, or is it? Well, it actually is, but it's not simplified. Why? Well, you can factor out a B squared from this. But that doesn't really do anything, does it? So if we write it back in, cosine squared of theta, and we write everything out again, like that. What do you notice is in this? It's just Pythagorean theorem with the trig function sine and cosine. And we know that sine squared of any angle theta plus cosine squared of any angle theta is equal to 1. So what we do here is erase this because it's messy and replace this with a 1. So it's B squared times 1, which is just equal to B squared. So this whole thing becomes B squared plus A squared minus 2AB cosine of theta, and we deserve a ginormous drum roll here. Rearranging to make it look nice. It is exactly the same if I zoom a long way out. Can you see it moving? Yep. it is the same, right? This can just simply be rewritten into, I'll write in the most amazing color, yellow. A squared plus B squared minus 2AB cosine of theta equals C squared. Woohoo! And that is it for law of cosines. Thank you very much and see you in the next video, and subscribe.